As a lift truck operator, your main goal is to use your machine safely and with precision. In order to do this, you must always have your truck under complete control. And maintaining control means understanding the principle of balance. The stability of a lift truck is based on the principle of balance. We are all familiar with the teeter-totter. To balance the teeter-totter, you had to have equal weight on either side of the center pivot point for the teeter-totter to balance. The center pivot point on a lift truck is known as the fulcrum. For lift trucks, the weight of the load and the mast on one side of the drive axle must be balanced by the truck's weight on the other side. The truck's offsetting weight for internal combustion engine lift trucks includes the engine, transmission, frame, steer axle, and counterweight. And for electric-type lift trucks, the offsetting weight includes the battery, panel, motors, frame, steer axle, and counterweight. As you can see by this diagram, the front wheels act as a fulcrum between the truck and its weight and the load and its weight. Now, let's consider the elements of a load. Every load has a center of gravity. The center of gravity is defined as the location within an object around which all weight is evenly distributed. And this definition remains true regardless of the object's shape. These three loads weigh the same, but because they have different shapes, they have different centers of gravity. You will often hear the term load center. The load center is defined as the distance from the face of the forks to the load's center of gravity. Most lift trucks are related to lift a specific weight to a specific height at a given load center, usually 24 inches. That means the load center of gravity must be 24 inches or less from the face of the forks in order for the truck to lift its rated capacity. The lift truck's center of gravity. Since a lift truck travels forward and in reverse, lifts, lowers, and tilts, its center of gravity moves. The lift truck's center of gravity moves forward as the mast tilts forward and moves back as the mast is tilted back. The center of gravity moves up as the mast is raised and moves down as the mast is lowered. When a lift truck picks up a load, the center of gravity of the truck and the center of gravity of the load will produce a combined center of gravity. Lift truck balance and stability are affected by both static conditions and dynamic forces. Static conditions can be affected by load characteristics. If load conditions are improper in size, shape, and position on the forks, it could affect the lift truck balance. Other static conditions include tire pressure for air-filled pneumatic tires and the dynamic forces created by motion, which include acceleration, speed, braking, lifting, lowering, tilting, and turning. Operating a vehicle on an uneven surface like a ramp changes the combined center of gravity, which affects its stability. By law, every truck must have a capacity plate. The plate contains information that is crucial to the safe operation of the lift truck to which they are attached. This information includes the load center, the load weight that the vehicle can safely handle, and the height the load can be lifted with the mast vertically. Another piece of information on the capacity plate is the offset dimension. Offset is the distance a load can move across the mast. The typical movement of the Cat lift truck side shift carriage is 4 inches either side of the center. So an offset dimension will not appear on the capacity plate. If a truck is equipped with an attachment with more than 4 inches of movement either side of the center, the capacity plate will show how many inches the load can travel horizontally and the net capacity of the truck. Other information includes the model number, serial number, and truck weight. On electric-powered trucks, the capacity plate will also show the truck weight with and without a battery, battery voltage, and minimum and maximum battery weight. In this example, the lifting capacity is 2,400 pounds. The load center is 24 inches to 188 inches with the mast vertical. Because truck capacity is dependent on load center and lift height, whenever the load center and/or lift height is increased, the amount of weight that can safely be lifted must be decreased. This is important because sometimes lift trucks are equipped with attachments other than forks. Attachments such as clamps or side shifters actually reduce capacity in two ways. First, the attachment can often lengthen the load center, thus reducing its load lifting ability. Second, the attachment's weight reduces the lift truck's capacity. You should therefore think of a truck with an attachment as already partially loaded. Before a lift truck's original design is altered with a new mast or an attachment, the federal OSHA standard says you must receive the lift truck manufacturer's written approval prior to making any modifications or additions that affect the capacity or safe operation of the lift truck. Once written approval is obtained, you must request and install a new capacity plate indicating the correct lifting capacity. The next part of your training should include an understanding of how lift truck stability is maintained. A typical lift truck has a 3-point suspension, the 2 drive wheels, and the center point of the rear axle. The rear axle pivots as a single point in the center to compensate for uneven surfaces. This forms the stability triangle base. With the lift height dimension added, a stability pyramid results. In order for a lift truck to remain upright, the combined center of gravity must remain inside this pyramid. If you allow the center of gravity to shift outside the pyramid, an imbalance will occur, resulting in a loss of steering control, loss of traction, unstable loads, and the potential for a tip-over. About 25% of all fatalities involving lift trucks occur when the truck tips over. To avoid tip-overs, it will help you to understand the principle of stability. Because the center of gravity of an object is not fixed, it can change when acted upon by certain forces. The combined center of gravity, which is created by a truck and its load, tends to move toward the edge of a stability pyramid under certain circumstances. Lateral stability can be lost when the center of gravity moves too far to either side of and crosses over the stability pyramid, causing the lift truck to tip sideways. Now, let's take these two trucks, one with a load 4 to 6 inches above the ground and one unloaded. If these two trucks had to take a turn quickly, which one would resist tipping laterally the most? The truck with the load? You're right. The combined center of gravity of the loaded truck is closer to the base of the stability pyramid than the unloaded truck. It has more room to move side to side before crossing over the stability pyramid. The closer the center of gravity is to the boundaries of the stability pyramid, the less it takes for the truck to become unbalanced and tip over. Longitudinal stability can be lost when the center of gravity moves too far forward or back and crosses over the stability pyramid, causing the lift truck to tip forward or backward. Sharp turns, braking abruptly, excessive speed, contact with an obstruction, traveling with a load too high and/or tilted past the vertical position, raised masts, and traveling over wet or uneven surfaces can result in the loss of stability. In addition, unstable loads, driving on ramps, and low tire pressure found on pneumatic lift trucks can affect stability and result in a tip-over. Avoid these situations and never lift or travel with a load that is greater than the rated capacity of your truck. Remember, it is your responsibility to maintain the center of gravity within the confines of the stability pyramid. By keeping your maneuvers smooth and slow, you will minimize the chances of losing stability and creating a tip-over. This is the end of Part 2. Please review the information you have been given and complete Part 2 in your workbook. When you are done, resume your training with Part 3 of this program.